Limits of entropy. Temperature and homogeneity. How big is a homogeneous zone of temperature? So take a sphere of measurement of a temperature. Inside that sphere, assume homogeneity. So everything is exactly, the temperature is exactly the same inside that sphere. What's the dimension of that sphere? It's Planck's constant. 6.6260715 times 10 to the minus 34 joules seconds. But Newton meter seconds squared is the unit. The hidden variable and the alternative reading. So you get lever arm duration area. That's the size of a homogeneous zone of temperature. Now, that homogeneous zone of temperature exists with a boundary around it, and the temperature around that boundary is different than the homogeneous zone. Now, that can't exist. Entropy says homogeneity must exist, so that boundary will be removed, and that the two temperatures will balance out with each other, and the homogeneous zone of temperature will increase in size in a sphere. Now, take that idea and say, well, how big would it go? And say it will be the size of the universe, the cosmos. The observed cosmos is the size of the universe, our universe, where we're at the center. That is the edge of entropy, of this homogeneous zone of temperature, where the temperature is all the same. But the distance of the sphere is now so massive that there is a duration of time created because of the motion of the temperature of the change of boundary. So that in order to make the center colder, because the center has the heat and the outside is cold, in order for that to reverse, the heat must escape from the center. And to do so, the surface will invert. So that the surface of the homogeneous zone of temperature at the center will inverse itself. But also each particle of that surface must also inverse itself. So it'll do a 720 twist. And it will leave a 90-degree twist at the end of the motion. So that it begins, the surface is twisted. So that the surface of the sphere, the homogeneous zone, is twisted. And that twist is 90 degrees. And then, in the next motion, duration of Planck's constant, real seconds, a tiny duration of time, real seconds, the surface does an inversion, 720, but like a Rubik's Cube, it's still one, the 90-degree twist is still remaining. And so you see the two helixes of DNA linking the information from one side of the moment to the next. That's work been done in the transmission of information from one place in another over a duration of time. And it's a duration of sound. The sound creates a resonance, and in that resonance motion, the surface does an inversion. But because it does that inversion in a duration of time, work is done, heat is created, and the twist remains. The 90-degree twist as described by Lewe. And now we can place the Earth at the center and see that that homogeneous zone is our atmosphere. That space is the cold out to the edge of the cosmos, homogeneous zone of coldness. We're at the center, a homogeneous zone of heat. Boundary, atmosphere. Inside that boundary, the 720 inversions repeats infinitely, manifesting each of those particles doing its 720 twists, manifests as light in the rigid body moment when the clamping action occurs at the limits of entropy. And so we found the limit. There must be a boundary. There must be two boundaries in this case, an inside and an outside surface. And they're inverted. So the inside surface and the outside surface are the wrong way around. Like a sphere. It's got an inside surface and an outside surface. Yeah? You look from the inside, look from the outside. What's happened in the cosmos is it's inverted, and that the inside is on the outside and the outside is on the inside. And so here this boundary must remain for all eternal time, because time exists eternally, life exists eternally, and humans exist eternally. Ready for the future in which the Earth is provably the centre of the universe through the description of entropy. Dr. V Lewe, 1915. Please reference that document in 1993. Professor Golgate, named. Reference your document or fuck off. Unfettered audit. Right now. That's it. Easy. Let the engineers take over. Follow the rebel king.